Hi everyone, this is Mr. Petrosino, and this is the third lesson of Unit 10, Exponents. Today we're going to be talking about two more laws of exponents, and that's the zero and negative exponent rule. So your objective will be to evaluate and or simplify expressions by applying the laws of exponents for zero and negative exponents, which pretty much gives a preview of our warm-up. Rewrite each expression with a single exponent and then answer the question that follows. So if you recall from the last lesson, when we are dividing exponents, we're going to actually subtract them because they have the same base, right? So we keep the 8. We don't divide 8 by 8 to get 1. We keep the base and we do 4 minus 4. Well, obviously 4 minus 4 is 0. Okay? It did not say to evaluate, so we don't have to plug 8 to the 0 power into the calculator. On the right-hand side, I have a variable as my base. They are the same. They're common bases, so we're going to subtract our exponents using the quotient rule. 3 minus 5 would give us a negative 2, so x to the negative second power. So my question to you all is, how are the results of these expressions different than yesterday or 2 days ago's lesson? What is different about these two expressions compared to the ones from the last lesson? Well, I think the clear answer is that the exponents are 0 and negative 2, whereas all of our exponents in the previous lesson were positive values. Right? The exponents are 0 and negative 2, whereas all exponents in lesson 2 were positive. Okay, so when we have exponents that are 0 or exponents that are negative, there's going to be different rules that are going to apply, which we're going to explore today. So what I'd recommend you do is try this part on your own. It's an exploratory challenge, so trying to figure out what the rules are without me just telling you. Again, if you're not up to it or if you're not feeling too confident, you're welcome just to follow along. So I want you to simplify on the left-hand side and then evaluate expression on the right-hand side using your laws of exponents. So the first one was done for you. 4 to the second power over 4 to the second power. Well, 4 to the second power is 16, 4 times 4. The same thing on the bottom. And when we divide two values that are exactly the same, we get 1. Now, if I'm using the laws of exponents, that means since the bases are the same, I'm going to subtract. 2 minus 2 is 0, so 4 to the 0 power. If I plug 4 to the 0 power into my calculator, we're going to get 1 as an answer. For number 2, 5 to the second power, so 5 times 5 is 25. On the bottom, 5 to the second power, again, is 25. And when I divide any value by itself, I get 1. We're going to continue on to the right-hand side. Well, using the quotient rule, since the bases are the same, I'm going to subtract 2 minus 2, which is 0. And if we plug 0 in for our exponent, 5 to the 0 power, we get 1. I'm going to continue that for question number 3, but now our exponent is a 3. Okay, keep in mind the exponent symbol on our calculator is the caret symbol. Looks like an arrow pointing up. 2 to the third power means 2 times 2 times 2, which is 8. Same thing on the bottom. And when I divide anything by itself, I get 1. I think we're starting to hopefully see a pattern here. On the right-hand side, bases are the same, so I subtract the exponents. 3 minus 3 is 0. 2 to the 0 power is 1. Last thing, even though we don't see an exponent here, there are 1s, right? But the 1s aren't needed because I'm only multiplying, or I'm only keeping 110. So 10 divided by 10 is 1. Whereas if I use the laws of exponents, forgive me, I'm tapping my phone as I'm typing or writing, there is a 1 and a 1 there. So 1 minus 1, again, would be 0. 10 to the 0 power on our calculator, it gives us 1 as an answer. So what do you notice about the value of each expression in the left column? So everything for 1, 2, 3, 4, and 5 on the left. Well, notice that when we simplify it, they all equal 1. What do you notice about the value of the exponent in each expression in the right-hand column? So what is the value of the exponent? I have a 0, a 0, a 0, and a 0. So let's think, what rule can we apply given these 4 examples? If on the left-hand side, they're always equal to 1, and on the right-hand side, the exponents are always 0. Well, if you guessed it, you are correct. Any number or variable raised to the 0 power is equal to 1. Okay? Think about why. If I'm dividing something by its equivalent expression on the bottom, right, 4 squared divided by 4 squared, I'm going to get the answer of 1. And if I subtract 2 numbers by itself, I'm going to get an exponent of 0. So 4 squared divided by 4 squared would be 4 to the 0 power, which equals 1. If we think of it in terms of our properties of exponents, right, in elementary school, you learned how to expand numbers out. Perhaps not in terms of exponents, or in this case, we're going to preview this in the next unit, scientific notation, but 5,000 is the same as 5 times 1,000, or 5 times 10 to the third power. 200 is the same as 2 times 100, or 2 times 10 to the second power, and so forth. But when we get to the ones place, what do I have to multiply 5 by to get 5? Well, it would be 1, and notice the exponent each time is going down. Right? Think of the exponent in terms of the number of zeros in base 10. 10 to the third power, there are 3 zeros. 10 to the second power, 2 zeros. 10 to the first power, 1 zero. But 10 to the 0 power has no zeros, so the equivalent would just be 1. So now a little think, pair, share. Now this is a common question that I've also seen in Algebra 1 in 9th grade. Are the expressions below equivalent? Excuse me. Justify your answer. So right away, when looking at the left and right-hand side, I noticed that they don't look the same. So my question to you is, what is different about both expressions? Well, on the left-hand side, we have parentheses. And those are important because we have to think of the order of operations. On the left-hand side, both the 8 and the x are being raised to the 0 power. Not just the x, not just the 8, but both of them. So if I'm raising 8 and x to the 0 power, the entire thing, right, going back to our rule, any number or variable raised to the 0 power is equal to 1. So since both are raised to the 0 power, it's equal to 1. On the right-hand side, again, thinking about the order of operations, well, in my acronym PEMDAS, exponents comes before multiplication, right? If I expanded this out, this would be 8 times x to the 0 power. I don't need the multiplication sign there because a coefficient next to a variable implies multiplication. But really, since there's no parentheses, only the x is raised to the 0 power. So x to the 0 power is 1, but then I have to multiply it by 8 to get 8. So are these expressions equivalent? No, they are not. Parentheses is incredibly important in math. So that's the first rule. Again, any number or variable raised to the 0 power is equal to 1. We'll do practice in just a moment. But now let's explore the second rule. When a number or variable is raised to a negative exponent, take the reciprocal of that number or variable and the exponent becomes positive. So that keyword reciprocal, right? Think of taking an expression and flipping it around and putting the numerator where the denominator is. So if I have something like 6 to the negative third power, that means that there are more 6s, 3 more 6s in the denominator than there is in the numerator. In math, or specifically for the rest of your high school career, you never want to have a negative exponent as your final answer. So 6 to the negative third power can be written as 1 over 6 to the positive third power. Or a to the negative fifth power can be written as 1 over a to the positive fifth power. By putting the exponent and the base in the bottom, the exponent becomes positive. Right? So in my guided task, this is telling me I have 3 4s in the denominator, or three more 4s in the denominator than the numerator. So I can rewrite this as 1 over 4 to the positive third power. Now, if you evaluated this on your calculator, these two expressions would be equivalent. If you wanted to simplify that further, you can do 4 to the third power in your calculator, but it does not say evaluate, it just says simplify. Now let me show you with variables to explain why this rule works. M to the second power over M to the fourth power. Well, let's do it the long way first. I have 2 m's on the top, and I have 4 m's on the bottom. Again, if I start just canceling them out, m, 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 I'm left with 2 on the bottom. But if I use my quotient rule, 2 minus 4, I get -2. So rewriting this as a positive, I have 1 over, right, I'm putting this in the denominator, m to the positive second power. How does that apply? There are 2 more m's on the bottom than there are on the top. We call that the negative exponent rule. So now I'd like you to try practice by applying both the negative exponent rule and the zero exponent rule. There are 8 questions I'd like you to try. I'd recommend pausing the video and trying them on your own, but if you're not feeling too confident yet, you're welcome to follow along. Notice here, I'm just writing it as an equivalent expression, and I do not have to evaluate, so you do not have to plug the entire expression into your calculator. So exercise 1, I have 5 to the negative third power. Think of the negative exponent as a non-simplified fraction. That is an expression, but that's not the final answer. To get rid of the negative exponent, I write its reciprocal by putting it in the denominator, 1 over 5 to the third power. Now again, I'm not asking you to evaluate, but if you were to evaluate, 5 to the third power would be 5 times 5 times 5, which would be 1 over 125. Okay, exercise 2, 2 to the negative fourth power. I want to get rid of the negative exponent, so I put it in the denominator. Now you may be asking, is that it? That's all we have to do? Well, as of right now, yes. Now it will eventually get a little bit more complicated, but this is a good first step, knowing that negative exponents belong in the denominator. Again, if you were to evaluate this even further, 2 to the fourth power would be 2 times 2 times 2 times 2, which would give you 1/16. Okay, but that would be evaluating. Here I'm just writing an equivalent expression. 19 to the second over 19 to the fifth. Now let's do it the long way, just to kind of show you or to emphasize how this is working. 19 to the second power is 19 times 19. 19 to the fifth power, here I have 5 19s. Right? If I were just canceling out, because anything divided by itself is 1, how many 19s are on the bottom? 3. Now the shorter way, or perhaps the shorter way, I can subtract my exponents. 2 minus 5 is -3. I don't want negative exponents as my final answer, so it goes in the denominator. The same exact answer. Now, exercise 4 is a little bit different, and it's applying the last lesson as well. Notice I don't have parentheses here, so these coefficients are not affected by the exponent. I simplify this as if the exponents weren't even there. Notice I have a multiplication sign, so I'm going to multiply 5 times 3, which is 15. But now, since my bases are the same, I'm going to use the product rule, so going back to the last lesson, and I'm going to add my exponents together. 2 plus -4 is -2. Now, think of it like a 2-point question on a test. Right when I used to be in class, I would tell you, well, why would I not get full credit? Because my exponent is negative. Now, the only thing being raised to the negative power is the m. So the m has to go in the denominator. And the exponent becomes positive. It's a +2, guys. Let's rewrite that over. 15 over m to the second power. Again, a common mistake here would be to include the 15 in the denominator, but only the m is being raised to the power. Let's look on the right-hand side, just some extra practice. X to the negative third power, right? I have 3 more x's on the bottom, so it becomes positive by putting it in the denominator. Same thing for exercise 6. Y to the negative fourth power. I have 4 more y's being multiplied on the bottom. Here, exercise 7 is where I have a coefficient. Again, applying last lesson. The 12 and 4 are not part of the exponent, are not part of the power. So I'm going to apply just my basic division rules. 12 divided by 4 is 3. But now, since these bases are the same, I'm going to use the quotient rule. What do I do with the quotient rule? I take the exponents and I subtract them. 16 minus negative 3. Okay, be careful with that negative. It's not 16 minus 3, 16 minus negative 3, which give me positive 19. I don't have to simplify that further because the exponent is positive. So here I didn't have to apply the 0 or the exponent rule, 0 or negative exponent rule. Last one, I have 1/7 to the negative second power. All right, here it's a little bit trickier because we have a fraction. Both the 1 and the 7 are being raised to the negative second power. Okay, so we want to put that in the denominator, 1 over 1/7 to the second power. Okay, here we have a complex fraction. And you know what, just to, I guess, make life a little bit easier for you, I'm not going to have to worry about that on your test. So just don't even worry about exercise 8. It is something you have learned, but let's just stick to the laws of exponents rules. Now, the last two, I'd like you to try these on your own. It says extension, but it's really more of an exit question. Which expression is not equivalent to 6 to the third over 6 to the sixth? And then simplify 5 to the negative 8th power times 5 to the 4th power. These are both questions that I have seen on previous assessments. Okay, so the key word here is not equivalent. So if I use my law of exponent rules, I'm going to subtract 3 minus 6 since they are the same base, and I get 6 to the negative third power. Well, I see that answer. I want the one that's not equivalent, so that one clearly is not the answer. If I rewrite this as a positive exponent, I have 1 over 6 to the third power. If I evaluate 6 to the third power, or 6 times 6 times 6, I get 216, so it's not choice C. So process of elimination, I get choice A as my answer. Last question, 5 to the negative 8th power times 5 to the 4th power. Notice here I'm not finding the one that's not equivalent. I just want to simplify it. So since I have multiplication here, I'm using the product rule, meaning I'm going to add the negative 8 and the positive 4. Negative 8 plus 4 is negative 4. I don't see that as my answer choice, so I'm going to rewrite it with a positive exponent, 1 over 5 to the 4th power. 1 over 5 to the 4th power is choice A as well. So just to recap, we have the 0 exponent rule. Anything raised to the 0 power is equal to 1. And for any positive value x and for any positive integer n, right? So here, if I have the negative exponent, I'm going to go 1 over x to the positive n. If you have any questions, please just shoot me a message. Again, for exercise 8, that complex fraction, just don't worry about it. I don't want to stress you any more than you already are. Hope everyone's doing very well, and take care.